All right, our next section is going to be about bar and line graphs. So we're going to take that data that we just kind of learned how to analyze in last section and work a little bit on putting it in visual form, such as graphs. The first graph we're looking at are bar graphs. Now, kind of a little bit different format for our notes here. Bar graphs should be used when looking at categories. So if you want to know how many people are in that play each sport at Canterbury, sports would be the category, and then obviously the number would be of each team. So looking at different categories of anything is kind of what you're looking for in the data. Here are some tips and things that need to go into bar graphs. If you just have a bunch of random data, you should always kind of organize that stuff into a table. Okay. First off, shouldn't just have random data. You should draw and label the horizontal axis, which is the x-axis here. Okay. And here, get a little thinner pen. And the vertical axis, which we call the y-axis. Okay, so that is the y-axis. Yikes. Sorry about that. Let's make this a little bit bigger here. The y-axis is the vertical. Okay, so that would be on this. This would be the y-axis. This would be the x-axis, horizontal. So y-axis would be here. You want to determine the scale, the numbered scale for the y-axis here. What a scale basically, it needs to accommodate all the data. So it needs to be able to fit all of your data. So what that means is you have to identify the smallest and largest data point and make sure that your graph is set up in a way that can fit that. Your scale also must have equal intervals. So you need to find the best way to go up each line here. So for example, if I was labeling this, maybe we go up by 5. So we go 5, 10, 15, 20, 25, 30, 35. So notice how they're equal. They all go up by 5. I can't all of a sudden just randomly decide I want to go up by 7 or something. You're going to make a bar for each category or piece of data for each category. So again, if you're using sports, you'd have a bar for every sport: basketball, soccer, volleyball, etc. You should also make sure you have a descriptive title for your graph, so some type of title. So just to let's just use sports. So notice this is has units on it, and if we're talking about students, we would say number of kids. All kids should be all axes should be labeled. Down here, we would put sports. Again, we would put we're looking at number of kids in each Canterbury sport. So again, you'd need a data table, but you'd have some bar going here. You'd label it volleyball. You'd have another bar, maybe a different color potentially, and you'd label that soccer, and so on. Okay, so you take the data, and wherever the data goes, whatever it tells you, you make a graph that goes up to that point. Now, if it says, let's say basketball, squeeze that label in there, b-ball is only 13. Well, there is no 13 on the graph. So you just have to estimate. 13 falls somewhere between 10 and 15. Okay, so we estimate. All right, notice everything is labeled, each axis is labeled, the bars are labeled, and the title has a label. So that's a bar graph. But notice on the x-axis, there's no numbers because those are where the categories go. So that's kind of your cue to making sure that's when you do a bar graph. When you have labels on one side, you have numbers on the other side. So let's look down below here, maybe. There we go. For a line graph now, for a line graph, the data normally involves two sets of numbers. So unlike here where we had like words or labels and then numbers, it's going to involve two sets of numbers. And this is key. A lot of times it looks at something over time, looking at how much a plant grew in inches over a period of days, something like that. Here are some tips for constructing line graphs. As always, you should organize your data into a table. You should draw and label the horizontal axis, which is the x-axis, and the vertical axis for the graph. Draw and label. Okay. Now, for this one, you need to determine the scale for the vertical, which is y, and the horizontal axis. The scale needs to accommodate all of the data. So identify the smallest and largest data point for each axis. Your scale must have equal intervals. So let's say I'm looking at, like I said earlier, plant height over, like how much my plant grew over the course of several weeks. So on the bottom, I could make my scale, so let's say I'm just looking at 4 weeks. I could make my scale go up by 1 each time. And again, of course, I'm going to label this if I can. I'm going to label that with what the data means. In this case, it does mean weeks. If I can do it, it's not letting me do it. There we go, weeks, because that's what that data is representing. Again, you normally have a data table looking this. We'll do some more examples in class. Over here, let's say we're measuring it in the plant height, plant size, and we're measuring that in centimeters. Always should give the labels there. And so let's say that, my highest data point is 50 centimeters or something. Well, I can't go up by ones. I don't have enough lines. So maybe I'll go up by tens instead. 20, 30, 40, 50. So each side can have its own scale. And of course, I should have a label, plant height, something of that nature. Okay. Now, here's the difference here. You're going to plot each data point based on what your data says. So if you have more than one line on your graph, you must also include a key showing what each line means. We'll get to that later. And then you connect the dots, and of course you write a descriptive title. So let's say your data table, which again we'll use data tables in class, says after week 1 the plant was 10 centimeters tall. I'm going to go over to 1 week up to 10 centimeters. Let's say after week 2 it was 25 centimeters tall. So I go over to week 2, and again there's no 25 dot, but I'm going to guess and say it's right in the middle, or no 25 line. Over to 2 up to the y-axis. Let's say after 3 weeks it was 40, and after 4 weeks it was 42. So I'm just going to make a little dot just above that 40 line. And then finally you should connect your dots. So that's a line graph. And again, it'll be a little bit easier when we're looking at actual data tables, which we'll do later.